All, welcome to Programmer's World. Myself Harish. If you are first time watching the videos in our channel, then I will give a short intro of it. So this channel completely deals with learning programming languages simple and efficiently. So if you are here to learn various programming languages in simple and efficient way, do subscribe to our channel and watch the videos and enjoy it. So let's get into the video. To take a look is we are going to take a look into the data types, and we are going to have a detailed explanation on what are all the data types available, and for each data type what is its purpose and how we are going to use it. So let's get into the video. So data types is commonly used in every programming language. So it represents what type of data that a identifier or a variable can hold it, either an integer data type or a string data type or a boolean data type. It represents the type of the data that is being stored in the variable. So when speaking about Python, so in the Python is one of the dynamically typed programming language. So as I said before, so Python doesn't need any data type to be defined explicitly. It will implicitly take the Python virtual machine will handle it by dynamically casting the respective type of the variable. We need not specify explicitly the integer or float or double or anything that. So in this video, we will have a short look on some of the data types, and in the next video, we will be seeing the left out data types. So there are almost 14 data types. We will see somewhat around 4 to 5 data types in this video, and then in the next video, we will look into the remaining data types. So the list of data types that are available in Python are integer, float, complex, bool, byte, byte array, string, range, list, tuple, set, frozen set, dictionary, and none. So, and as I said, the Python contains some of the inbuilt functions. The purpose of these inbuilt functions are usually to each of these has some different functionality. Here I have listed some of the main inbuilt functions like type. So this function is used to denote what type of variable it is, whether it is using this function we can know what type of variable it is. And id function, this function returns the identifier, that is the to which memory id location the respective object is being referred. It gets the address of the object. And print is simply used to print the value actually. So in Python, we are going to everything deals with the object only. So there is not a primitive, those kind of stuff. So everything deals with purely objects. Okay. So I'll just show, okay, I will just illustrate it. So suppose in the Python IDE, I'm type the C equal to 10. Then I'm giving type of A. So type of A, I'll be getting what type it is. It is of class integer. So why it is defining as class integer is, as I said, in Python everything is object. So it's stored in the form of classes and objects only. So the A variable, the variable A holds integer value, so it is of type class int. And then we can get the id function also, which where we get the location of it. So this is the memory address location where this A variable is being located. So let's start with the data type. First we'll look into the integer data type. So the integer data type, it represents the whole numbers. Simple 1, 2, 3, those kind of whole numbers are represented in this kind of integer data type. So that's what a simple sample example I have shown here. And in Python 2 version, what we had was we also had another data type known as long. So the purpose of having this long data type was to store a high range value. So to store a large integer value, we used to have a long data type. So as we had for other languages like Java and all, we have long and double. So similarly in Python 2 version also we had the long data type. But when it comes to Python 3, in Python 3 the long data type has been removed and then it has been replaced with the int data. So it is not that to represent a large integer value we need to specify long data type. Integer data type is more than sufficient, and integer data type can hold any mode of large integer value. So this is one of the point to be noted. And then so this integer value int data type can be represented in some various forms. There are 4 different forms in which the integer values can be represented. Those are decimal form, binary form, octal form, and hexadecimal form. We'll see what these forms denote one by one. First one is the decimal form. So decimal form is nothing but the base of 10. So in the decimal form, it is one of the default one. So in the integer values, by default, this decimal form only is used. So the list of allowed digits in decimal form is from 0 to 9. So these are all the allowed digits. Uh, it's just a normal denotation like a equal to 10. So these kind of stuffs and all comes under decimal form. And then the binary form is of base 2. So this binary form will hold only digits 0 and 1. Apart from this, if we give any digits, it will not be accepted. So that's the thing. So the literal value of the binary form should be starting with the 0b or 0 caps b. It can be small b or capital B. I will show it. So a equal to 0b. So print of a. So it represents the 4 value. This one I will explain why it's coming as 4. It while printing the print function will by default print only the decimal value form of variable of base 10. It will not include or take into consideration either any binary form or hexadecimal form, so or octal form. So these forms are not considered by the Python virtual machine. So that's why. So 0b100. If I give 0b123, so it will throw an error like invalid digit 2 in binary literal. So we cannot give these kind of digits. So ones and zeros are only allowed in binary literals. So this one is allowed, this one is not allowed, and then this one. It starts with B1111. So if I take this B1111, it throws like name B11 is not defined like that. And then the same the octal form. The octal form is of base 8. So the binary form is of base 2 and the octal form is base 8. So this followed digits are 0 to 7 and the literal value would be 0 O, small o, caps O. So 0 to 7 is only allowed. And then the hexadecimal form is of base 16. So list of allowed digits are 0 to 9 and A to F. In the A to F, both lower and upper cases are allowed, irrespective of cases. So these are all the allowed digits, and its prefix should be 0, small x or capital X. So, and then so these are all the list of various forms that can be that integer value can be represented. And then, as I said, being a programmer, we can specify the literal values either in decimal or binary or octal and hexadecimal form. Whatever form we can specify it. But when the Python virtual machine is executing and perform some operations on the value, it will work on the decimal form only. It will return the output in decimal format only. So as I say, as we see here, so if I give 0b100, sorry, 0b100, so this is a binary form representation of a decimal value. So the output would be the Python virtual machine would be giving the value 4. It would convert the binary form into the decimal and it will provide the result. So if I give 0 octal representation of 100, it will give the equivalent decimal value for that octal representation. If I give 0x100, it will give the hexadecimal representation of it. So the Python virtual machine will completely provide only the uh, decimal format irrespective of whatever input form we are giving. And then we are having some base conversions. That means here I have listed out 4 forms. We can convert from one form to other form with some of the base conversion methods that are available. So there are 3 base conversion methods available in Python. One is bin, and the other one is out, and the last one is hex. So as the name itself denotes, the bin function would be converting from any base form to binary, and the oct would be converting from any base to octal, and the hex would be converting from any base to hexadecimal. I'll just show a short illustration of it. So if I give bin of 0, 100, I am converting the octal representation to binary form. So it will print the binary representation of it. If in the bin, if you are giving the binary representation itself, then also no issues. It will just print the same value here in the bin. The same for octal. We can convert anything 0, B100. I am converting the binary to octal, so it will convert and give the necessary result. And the same for hexadecimal. So I am converting the octal representation to hexadecimal format. So it will list out the hexadecimal output. Okay. So this is about the base conversions. And then the next data type is the float data type. So the float data type is nothing but is to hold the decimal values. Decimal values in the sense floating point values. So to hold the floating point values, we are using the data type known as float. So this float in Java, if you take a look at how we will be denoting this, we will be denoting with the suffix f followed by the value of the value. Suppose if there is 1.234 is the float value, then how we would be specifying is 1.234 f we would be specifying it. But in Python it's not necessary. If it is specified directly any decimal floating point value like point, it will take into the consideration like it is of type float. Okay. So one of the thing in the float variable what we can do is we can specify the exponential form of it. That is the scientific notation where converting from one form to we can convert into the multiples of the exponential form that we are specifying here. So e power 3 gives you the result for 100. So e power 3 is into 1000. Sorry. So I'll just show a short illustration. So if I give 1.234 e power 3, so it is going to multiply the value that has been given, the 1.234 into e power 3 means so the 1000. So into 1000 it will provide the result. If I give 1.234 e power 2, so it is going to multiply into 100, the 1.23. So this is just the exponential notation. There is no difference much about it. We can give small e as well as capital E. That's how it is. There will not be any syntax error. So the main reason for advantage of using this exponential notation is to represent big values in a short-term memory. So for that only we are using it. So the thing, one of the point that needs to be noted here is the integer values can be represented in decimal, binary, hexa and octal representation. But whereas the floating values cannot be represented in this hexadecimal, octal or binary representation, it can be represented only using the decimal form. And then the complex data type. So the next data type, the complex data type, is somewhat used in scientific applications. So for electrical and some of the scientific applications, this complex data type would be used. So similar to mathematical thing, the complex data type is the one which holds the value in real and imaginary part. I just showed a sample illustration of how a complex number would be looking like a plus bj, where a is the real part and b is the imaginary part. So in the place of a and b, we can give some numbers. So and j is the prefix, the suffix which denotes it is of a complex type. So usually in mathematics you would be representing it in the form of pi. So in Python, to denote a complex number, it is the representation used is j. So in the real part, if we are passing some integer, that is 1 to 3 or like that, we can give it in a decimal format or a binary format or a hexadecimal format, whatever format we want. But when we are giving in the imaginary part, it should be of only decimal format. It can be either integer or float, but it cannot be of type binary form or hexadecimal form. So it can be only of decimal form. Whereas the real part can be of anything. If you are giving an integer value, it can be of any form. Hexadecimal or binary, it can be anything. So that's the thing which needs to be noted. And then in the complex data type has some predefined attributes to list out the values actually to get the real and imaginary part. So I'll just show it. So I am just declaring the complex value c equal to 10 plus 3.5j. So when I put c dot real, so this real attribute would be listing the real part of the complex variable that is present. So I'll be getting 10.0, and if I go c dot image, I'll be getting the imaginary part of the variable. So c dot image will list out the imaginary variable, and c dot real would be listing out the real part of it. And as I said, this complex data type is generally used in scientific applications and electrical engineering applications. And then the next data type is the bool data type. So the boolean data type is the data type which is being used to denote true and false. So the list of allowed values in boolean data type is true and false. Internally, similar to Java, the Python, true denotes 1 and 0 denotes false. So it's the representation. So I just shown a sample. So a equal to 10, b equal to 20. And I am comparing it with the lesser than operator, that is less than b. And if we print c, c is of type boolean, because a less than b will be resulting in either true or false. So the boolean data type, and c will be printing the output true. And here one thing is, in Python we can do some arithmetic operation with the help of the constant like the true and false. So if we do the arithmetic operation, it will perform less like the Python virtual machine will take the true as the internal representation 1 and false as 0, and it will do the arithmetic operation. So here I have denoted this. So true plus true. So the internal representation of true is, as I said, 1. So 1 plus 1 would be 2, and then the false also it would be. So when we are doing some arithmetic operation by overloading the operator, the boolean data type would be converted internally by the Python virtual machine to its respective integer variable value. And then the next data type is the string data type. So string data type is the data type used to represent a group of characters or a single character. So the string data type can be represented in single quotes or double quotes. Usually in Java and C, C++ and all, if we represent a string value with, if we represent an alphabet with a single character, then it's of a type char. So in char we can only give a single alphabet. So in Python there is no specified data type called char. It's only one data type is available, string. We can specify n number of characters we want inside the string. So it can be denoted either using single quote or double quotes. So, and we can use triple single quotes also. I'll just illustrate why we need to do it and what is the purpose of using the triple single quotes. So, as I said, with the double quotes, I can give any value. So, the string, and it will print the output. Even with single quotes also, it is acceptable. So, the purpose of double quotes, that is the triple double quotes or triple single quotes, is if we want to give a multi-line literals, that is, suppose I want to give Harish, and in the next line, the new line I want to give. So if I give enter and type is so any other statement, it will throw like end of line while scanning the string literal. It is expecting this one, the double quotes to be closed. So if you want to give some new line literals like a set of multi-line statements, then we can use triple double quotes or triple single quotes. So Harish, and if I give enter now, it will be stating with three dots. So now it will not be throwing error. We can proceed with. So we can proceed n number of lines until we give another triple double quotes to end the statement. So I will give another is a programmer. So now if I give triple double quotes, it would ended up and the output would be like this. Harish slash n is so we are giving enter, so it will take it as a new line character and it says printing the escape character of the new line. So like this you will be getting, and this is the purpose we are using triple double quotes, and or you can use triple single quotes also. And one of the another reason for using the triple double quotes and triple single quotes is we can, if we want inside the string to have a double quotes or a single quote, then we have to use triple double quotes. So I'm using triple double quotes. Harish is a programmer. So in programmer, if I want double quotes to be specified, so I'll be specifying it here. I am specifying it here, and then I will be giving double quotes. So now I will be getting the programmer word highlighted with double quotes. So this is the purpose of giving triple double quotes in Python. And then the thing is the slicing of strings. So slicing means cutting off. So taking a part of a string and doing some operations on it. So that's what here slicing is all meaning about. So the slice is represented with the subscript operator. Like this is the representation of opening and closing subscript operators. This operator is called as a slice operator, which can be used to retrieve the parts of the string. So similar to other languages like Java and C++, the Python also, the string index starts with 0, and we are having the reverse indexing also. So it would start from -1. So the positive index would be starting from 0. That is the positive index starting from left to right, and the negative index would be starting from right to left. So with this, what are all the operations that we can perform is with the help of slicing? Yes, I'll just show it. So I'm just declaring a string. So I will give it as I'll give this string itself. Harish is a programmer. So I'm giving this string. So the slicing operator, that is a, if I give 0, I will be getting h. So in the 0th index, this is present. So I will be getting the value that is present in the 0th index. Apart from this, we can do some other operations like a. So I'm opening the bracket and 0. and if I give this colon, and if I give some value like 5, so what it will do is, if you take a look in the output, I'm getting the output as 5. So if you take a look in this value, the H should be holding in 0 and A would be in 1. I'm speaking about the index. H is in 0, A would be in 1, R is in 2, and I is in 3, and S is in 4, and H is in 5. So what this kind of representation A of 0 to 5 means, it would be printing the character starting from 0 index to n minus 1, the value. So 5 minus 1 is 4. So it would be printing from 0 to 4. So the index till the index 4, it would be printing the value. If I give simply A of 0 true, and I don't specify any end value, so I'm just taking a part of the string. So 0 to n minus 1, if you give 10 means, it would be printing from the index, the list of values present from 0 to 9. So it would be printing it. So, and if I give A of, I'm giving the starting value of 0 and I'm not giving any ending value, and if I just close the bracket and print it, it would start from 0 and print the entire set of string. So if I give some 4 like that, and without any end I am closing it, it will start from the index 4 and it will just print the rest of the statement. Similarly, without specifying start also we can do it. Without specifying start, we can just give the colon and we can specify at what value to be ended up. So if I give some more 4, then it will print from 0 to, it will print till what we want to end. If I don't give both start and end, then what will happen is, it will just print the entire string. You will not be getting any exception or error. So inside this slicing operator, we can give either positive index and we can give also the negative index also. So if I give to A of minus 2, so what we will be getting is the minus 2 this value. So minus 1 would be R and the minus 2 would be this value A of minus 2 is C. So I'll be getting this variable value that is being defined here. So even the negative index can be given inside the slicing operator. So I'll be giving like what I'll be giving is E of that gives us minus 3 which start and it should end with minus 1. So if I give like this, it would be printing minus 3. So it would be starting with this one, minus 1, minus 2 and minus 3. So the M would be starting and it be minus 1 is R. So n minus 1 minus 1 minus 1 it will be minus 2. So M and E are getting printed. So like this we can do the splitting up of strings with the help of slice operator. And then we can perform some concatenation and arithmetical operations also. Suppose A multiplied by 2. If I do like this, what I will be getting is, I'll be getting the output like this. Harish is a programmer is first printed and it's printed 2 times. If you give into 3, it will be printing 3 times. So like this, some arithmetic operations can also be done in with the help of the string data type. And then we are having the function known as len. So the purpose of this len function is usually to get the length of the string. So length of A is 22. So length would be starting from the index 1. So length will not start from the index 0. So length would be starting from the index 1. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So the length would be starting from 1. So and as I said, in Python we can represent the character values also by using the string, and explicitly char type is not available in Python. So this is all about the string data type. So the rest of the data types like byte, byte array, list, tuple and all you'll be seeing out in the next video. I hope you like this video. If you like this video, please like it and please subscribe to our channel and watch the videos regularly. Thank you.